took my teacher course one time, they were like, never apologize for anything ahead of time. I'm totally about to do that. Bless you. I'm not going to apologize so much as tell you, you might feel some frustration in this lesson. Okay, because I want you to please raise your hand if you have never solved matrices by hand before. Not by hand, yeah. Okay. We are going to take, it's not a hard, difficult process. But today it might feel difficult because we're going to do it nice and detailed and slow so you understand what's going on. Once you get the hang of it, it ends up going really fast, right? And the ultimate goal for the lesson, if you look at the back of your notes, what we're working up to is taking this system right here. It's also on the I will board up here. You know how to solve a system like that already. We did that last unit. But what we're going to do is put it in matrix form, and I'm going to show you how to do the math on the rows to simulate the same work we would have done last unit. Okay. It requires some new kinds of notation, meaning just symbols, like the way we explain it with symbols, that you might not have seen. You might feel a little bit, weirded out about because you're uncomfortable. But, discomfort is good. It's how you grow. So we're all going to survive. We're going to begin, this first side of the notes is not actually solving anything. It's just practicing the baby skills we need to solve the matrix in the second half of the lesson. So this stuff we're about to do accomplishes two things. One, practice learning the notation or symbols, like this right here, that we're going to be talking about or using this unit, this kind of stuff. What does that mean? And then the second thing we're going to accomplish is how to do math on the rows. And that's why this up here at the top of the screen, elementary row operations. Well, in math, operations are what? Add, subtract, multiply, divide. The rows are what? The horizontal things on the matrices. So we're going to be adding, subtracting, multiplying, and dividing those together, which should feel a little bit intuitive to you because we just did that last unit with the systems, with the x's, the y's, and the z's in the equal bars. Okay. So again, this first half of the notes is really just basic skills. There's not a larger context. We're not solving the matrix. We're just exploring how it works in the symbols. So what I've got is this matrix here. Some quick review from yesterday. These things going left to right are called what? And the things going up and down? What does this bar represent? Equals. Okay, and what do we call these? These are constants. These things on the ends are brackets. Which numbers represent the y values of the system? 4, -8. And so 7 and 4 represent the coefficients for the x's. Okay, so we're all good. What do you think this right here is telling me to do? Multiply row 2 by 1/4. What do you think this arrow is telling me to do? What do you think? Equals. It'll be the new row 2. All right, so let's go over that one more time. We're going to take 1/4 of everything in row 2, and that will become our new row 2. And that's what this space right here is to do, is to write that new modified matrix. So row 1 is going to stay the same. And then we're taking 1/4 of everything in row 2 for no real good reason other than we can, and we're just practicing. So 1/4 of 4 is 1, 1/4 of -8 is -2, and 1/4 of 12 is 3. So we went from here to here, and now we have this new matrix. Okay, that's just trying to illustrate that you can do any math operation you want on any row and make a new row from that math. So we have this matrix here. We're still continuing with this new matrix down here, where we're going to do this operation. What do you think this symbol is telling me? Switch them. We'll just flip them. Make row 1, row 2, and vice versa. So using this modified matrix, now you're going to make one more new matrix. You're just switching the rows. And I'll explain in a minute why you might even want to do that in the first place. I'll show you a little bit later in the lesson. All right, so kind of good so far? This was just practice, didn't really mean anything. Didn't we need this up anymore? Okay, so we have this new matrix. Again, remember this, always keep in the back of your head, this represents equations. 2x plus 1y minus 1z equals negative 3, for example. The first part of the instruction says, perform the indicated row operations and write your new matrix. So this one's a little more involved than the last one. This one's telling me, what is this piece telling me I'm going to do? Multiply what? Row 1. What is this piece telling me? Row 2 by 2. What is this telling me? Equals the new row 2. But my question for you is this. I'm doing math on row 1, right? I'm going to do negative 3 times row 1. However, the only row that's actually changing in the new matrix is row 2. Okay? I'm just using row 1 for some math, but it's going to stay the same. So whatever comes after the arrow, that's the only row that's changing. Only row that's changing. So I'm using the other rows for math purposes, but I'm only changing row 2. So in fact, before I even do any math, I'm just going to go ahead and fill in the first row and the third row right now so that I don't accidentally trick myself into changing them up. So row 1 is going to stay the same in the new matrix. Row 3 is going to stay the same. I'll only be changing row 2 when I do the math. And we'll talk, and once we do that, we'll talk more about why we even did this in the first place. So I'm going to do negative 3 times all of row 1. I'm going to do 2 times row 2. You can do this in your head if you like. I'm going to be showing it up here in case you're visual and you need to see what exactly the baby steps were. So negative 3 times row 1 gives me negative 6, negative 3, positive 9. And 2 times row 2 gives me 6, 2, 2, and 0. And then I'm going to add those. So this is negative 3 row 1, 2 row 2. I'm adding them. I have 0, negative 1, 5, 9. And where is this going to go? My new row 2. So looking at this information, and thinking about everything we did last unit in solving, what important thing has just occurred here in this row that I care? Jasmine? I got rid of one of the variables. Okay, there's the x is gone. Remember when we were solving systems of 3 equations in the last unit, we would do elimination twice to get rid of one of the variables. We would take those 2 new equations, do elimination again to get rid of one. Well, this is the first step in that process using matrices. I've eliminated a variable. And so the reason why this was negative 3 and this was 2 was because looking here, that's what we would need to multiply those by to cancel them out. Okay, so we went here. Now we're going to go here. So looking at our new modified matrix, by the way, as you continue through your matrix problems, once you've changed the original matrix, you're just kind of leaving it alone for a while. When I do the next set of the row operations right here, those will be happening on this new matrix. Okay, so when I do my new row operations, it's going to be on this new one. So when it says negative 2 row 1 plus row 3, I'm using those. So what's happening with, if I do negative 2 times row 1, well, let's just do that. So negative 2 times row 1 goes here. I'm going to do negative 2 times this. I'm going to add it to row 3, and it's going to give me my new which row? Row 3. What will be happening to rows 1 and 2? They're going to stay the same. In fact, we're just going to fill those in before we do anything so we don't mess ourselves up. So 1 and 2 stay the same. So you do your math, I'm going to do mine. Negative 2, row 1. Add it to row 3. Gives you any more time before I talk. All right. What happened here? Now what? I eliminated x twice. If this was a system of equations, then we would have these two with y and z. We would do elimination one more time, and we would move on. Okay. So what we've just done is the same thing we were doing last unit, but we used a matrix instead. Okay. In theory, as you get better at this, it's faster than doing it with the x's, the y's, and the z's in there. Okay. All right, so we have that. So my next thing I want to ask you on the instructions up top for the example, it says what row operations would produce zeros beneath the first entry in the diagonal? Change this word first, change it to second. I like this question better. So right now I have zeros underneath the first entry in the diagonal. I want to know, I'm asking you now, what row operations would I need to do to get a 0 under the second diagonal entry? Well, what is the second diagonal entry? Remember our definition of diagonal entry? What's the second entry in the diagonal? -1, right? Yesterday we talked about how the diagonal goes here to here, upper left to bottom right. So this is the second entry in the diagonal. What would I need to do to get a 0 here? Add row 2 to row 3, right? If I added row 2 to row 3, this would give me 0, these would give me 0, okay? And this would give me my new which row, by the way? Row 3. Why would I even care if I had a 0 here as well? Why would that make me happy? There'd be a triangle of zeros here, and we talked a little bit about that yesterday. If I have 2 zeros here, what's going on then? Why would this, come on. That's exactly right. There's only one variable left here, then we could solve for it, and then we could back substitute, okay? And that's our main goal when we're solving these systems using that's called triangularizing the system. When you have these zeros in a little triangle at the bottom. Does anybody need this up before I change the screen? Okay, and I just went from yesterday. So by the way, the screen I'm about to show you is from yesterday. It's not on your notes today. It's not on your notes today. Please don't yell at me. Where is it? Because it's not on your notes today. It's from yesterday. We did this problem yesterday in our notes. The triangularization was already done for us. So the only extension we're doing on today's lesson is figuring out how to do that ourselves. And this was easy yesterday. Remember, we were like, z is 8, and then we plugged it in, and then we plugged it in. We did our back substitution. So our goal for the lesson today is to do this ourselves, which is why we just practiced all the skills a second ago in those example problems. Okay, back to today's notes. So these are the steps we're going to use now to solve this system using a matrix, okay? Aaron, please read me step 1. Thank you. Please raise your hand if you remember what an augmented matrix is. Does anybody remember? Yeah, we put them together, right? We put the coefficient matrix and the constant matrix together with the line in the middle of, or not in the middle, but representing the equal signs. So you take a minute, and this is step 1 for triangularizing our matrix, and do that. I'm not even asking you to do any math. I want you to take this system of equations and write it as an augmented matrix. Okay, do y'all have this? I'm pretty sure you're perfect. I just want to double check because we were missing a variable in row 3. Be sure that you put the 0 in the y spot. It's real easy to just see it shifted over and say that x is 0, y is 4, and z is -2. But pay attention that 4 goes with x, so it's in the x column. Who's here? Who's good to go? Who got all this? All right, perfect. So now we start our math, all right, our row operations. So step 2, so going back, I'm switching back over to the step screen. Cecily, read step 2 for us, please. Okay, perfect. So that's saying something very specific there. There's a particular order to getting your triangularization done. This says we want to get zeros under the diagonal entry in the first column. We need 3 altogether, but the first 2 we're focusing on is in the x column. Okay, and that's for a reason. So we go back here. So that says you want zeros under the first entry in the diagonal. That's this right here. So step 2, we are not going to proceed from step 2 until we have a 0 here and a 0 there. All right. And so we're just going to start with this one. It doesn't really matter which one you start with, but we'll just sort of go from the top down just for our system. So looking at these rows, if I want a 0 here, use your brain, don't holler out, but try and figure some math I can do so that when I add 2 rows, I can have a 0 here. And raise your hand when you think you figured that out for yourself. Yeah. So you're trying to figure out some math you could do to the rows so that when you add 2 of them, you get a 0 right here. Bella, what'd you come up with in your brain? -2 times what? Okay, so you're telling me -2 times the second row. That's good. And you'd add it to which row? To the first row. And that would give you your new which row? Second row. Very good. Okay, so this is what we're going to do. -2 times the second row plus the first row gives me my new second row. So take a minute and do it on your paper. And I'm going to do mine up here. Did y'all get -5, 5, and 20? Okay. And this is going to be my new row 2. What happens to the other 2 rows? Stay the same. Okay. The other 2 rows are staying the same. how do I know that I'm not done with step 2? How do I know that I'm not done with step 2? Step 2, go ahead. I need another 0 where the 4 is. So please keep in mind, step 2 is you're using row operations to get zeros under the first diagonal entry. So I have 1 0 there, but I still have a 4. Okay, so I've essentially eliminated x here, and now I'm trying to eliminate x here in this row. So what kind of math can I do so that I can add 2 rows and have a 0 right here? What? By -2. Yeah, I knew where you were going. So if we multiply row 1 by -2 and add it to, John, which row were you going to add it to? Okay, and that will give me my new which row? Row 3. Okay, so you do your math, I'm going to do mine. I need a taller smartboard. I might have skipped a step. Did I skip a step? I think I might have skipped a step, you guys. I think I went. I'm sorry, y'all. I'm sorry. I kept scrolling and I was like, I'm over the scrolling. I'm just going to copy from my notes. And then I skipped the whole step. My bad. I apologize. Is that better? Yeah, okay. I did not mean to make you question all of your math skills. I had an excellent question. Sorry, y'all. I skipped the whole step. So I had a good question. If once we do that math, we lose the 0 that was right here, that's fine. We're going to take care of that in step 3. Okay, that's not a problem. What we don't want to do going forward is undo either of these zeros because we just worked really hard for them. But this 0, that's fine. We're going to fix it in the next step. So now that we have zeros in both of these places, we've completed step 2. We're moving on to step 3, which is to get a 0 right here. Okay, so I'm going to go over here and do step 3. Bless you. So what we have to do now is think of some math to get a 0 there. But again, it's not, you have to sort of be careful. If you go back and look at your notes here on step 3, utilize elementary row operations with what? Row 2 and row 3. That's very specific. And we're going to talk about why it's that specific. To get zeros under the second diagonal entry. So looking over here at the progress we've made so far, that step is telling me you can only work with rows 2 and 3. Why do you think that is? What if I did some math with row 1 and added them? Emma? There's a very good chance it undoes my zeros right here, right? Because there's a number in that first entry. So you just want to leave row 1 alone for this step. It's fair game for step 2, But now that we've moved on to step 3, we only want to focus on these 2 rows. So your job right now in your brain is to think of some math here with just row 2 and row 3 that will get me a 0 here where the 2 is. So I want, all right? So you're doing math on row 2 and row 3 that will get you a 0 where that bottom 2 is. Did you have an answer? It's an emergency. Do you have an answer? Okay. What math did you come up with? What do y'all think? No? No, no? Who's kind of like, I don't know. Anytime you're stuck, you really can just multiply the 2 numbers to get the opposite by themselves. Like, for example, -5 times 2 and 2 times 5. Okay, one of those was already negative, so I don't have to mess with that. Okay. So 2R2 plus 5R3 will give me which new row that I want. -2, and then it would have to be, yeah, -5. Yep. Mm-hmm. Yep, no problem. Thank you. And this is going to give me which new row? 3. Row 3. Okay, you do your math, I'll do mine. And this is where the numbers came from that I have put up there. So even though I did math on row 2, right? I did math on row 2 to get my new row 3. I'm not changing row 2 when I rewrite my matrix right now. So I've got this now. Row 1 stays the same. Row 2 stays the same. Row 3 is now that. And by the way, this goal of triangularizing might be why you would ever want to switch the rows around. One of those beginning examples, we just practiced that double-headed arrow where it just means switching the rows. If you had done some math and these in row 2 and row 3 were reversed, but you were thinking critically and you're like, oh, it'd be really nice if those zeros were the other way, you just switch them. Okay, that's not a problem. Okay, how come even after all that work and like half a day later, we're still not done with the problem? Yes, you have to back substitute, right? But at least now it's not going to be hard. Here's our triangularized zeros. What does this bottom row even mean? -30z equals -90. How many variables are in that equation? 1. So that's we can solve that, all right? So I'll begin that process. I'll put it in blue so you can see where I'm going. So starting with row 3, starting our back substitution. So z equals 3. What am I going to do with that? Okay. Go to row 2. and plug it in. Row 2 means 0x, negative 5y, plus 5z, but now what do I know about z? It's 3 equals 20. Okay, so this is me plugging 3 in for z right here from row 2. Okay. So that's 15. Subtract it to the other side. Gives you negative 5y equals 5. Y equals negative 1. And then we take those two things, we back substitute to the first row. This is all my back substitution. The first row is 2x minus 1 times y, and now I know y is negative 1, plus 3 times z, which is 3, equals 14. So that's 2x plus 1 plus 9 equals 14. That's 10. Move it over gives you 4. Dividing gives you 2. And I still haven't written the actual final answer. What's your final answer? Right, an ordered triple. 2, negative 1, 3. Congratulations, you survived your first day of solving matrices by hand. You did well. Good job, team.